Welcome to Birla Industrial Technological Museum, one of the most unique science museum in Eastern India. It's definitely a worth visit, especially for the kids in the school. So today I am representing my school as a coordinator, and we are invited to attend an astounding lecture session by Dr. Debiprosad Duari, the director of Institute of Astronomy, Space and Earth Science in Kolkata. The museum offered various exhibits and different galleries, so I'd request all the students at least to visit this place once in their lifetime. So today I'm a little bit hurry, so let's join the program first. After that, I will show you the different galleries of BITM.
The Royal Society of Chemistry, Eastern India section, welcomes you to our star-studded 23rd Nirupova Memorial Lecture, Cosmic Concepts. Psychologists have found that confronted with something vast, something that dwarfs you, and something that's beyond your capacity to comprehend.
In the coming 1 hour or so, we'll be discussing about a subject area of which I think 90% of you have done a school project, astronomy. That's the general trend. No, not you, I understand. But it has become a happening subject. And let us talk about this particular subject area. But before I start, I should thank the Royal Society of Chemistry for continuously putting on this effort, the energy, to do something positive in this part of the country. And for the last 30 years, this is a great thing that has happened. And this is a memorial lecture, so I start by giving my respect to the departed soul in whose name this memorial lecture is being done. It is getting portrayed, but about the challenges that these pictures are posing to our human mind. Look into the sky, just to wonder, what is sky? Where is sky? What are those lighted dots we call stars? And is there any connection between the star and the earth? With these set of questions and queries, the subject of astronomy was born. So astronomy can be considered as one of the oldest subjects that human minds have dwelt upon. At the same time, given the huge number of news items that you regularly get to see in television channels and newspapers, you get an idea that it is also one of the most happening subjects in the recent times. Astronomy as a subject has a power, it can tell us what was the physical situation in this particular area that you are sitting now, millions of years back. Functional. The world's largest telescope is going to be called TMT, 30-meter telescope, a telescope with a 30-meter diameter mirror at the heart of it. The cost of building this telescope is so huge, not a single country is able to build it. 5 countries are collaborating: USA, China, Canada, Japan, and India. In 2018, the then Prime Minister declared in the Lok Sabha, the Indian contribution for building this telescope will be 1700 crore rupees, one instrument. And that tells you, in India, though we invest in spectrum radio waves, and the atmosphere is transparent to radio waves, so objects are observed in radio waves. And this is one of the fine examples. Do you know the diameter of this? 100 meters. In Germany, Effelsberg Radio Telescope, that tells you about the technological advancements. Space-time has a 2-dimensional rubber membrane, very stretched rubber membrane, say like this, we have attached it with a hook. Put this object in the rubber membrane. It goes down a little bit. Put this, is heavy. Goes down a lot. What happens between the rubber membrane, in the rubber membrane between this and this? It gets curved. So can it stay here? It will start rolling and touching. I sense that this is gravity. It is not attractive force. Any object, because of its mass, creates a curvature in the space-time. And that curvature will tell other bodies how to approach it. General theory of relativity. So in this concept, if two heavy objects, very heavy, very small, they are going around each other very fast, what will happen? A ripple will be created in the space-time called gravitational wave or gravitational radiation. 2015, it was discovered by two fantastic labs of Caltech called LIGO, Laser Interferometric Gravitational Observatory. 4 meter by 4 meter. The total vacuum inside is 10 to the power minus 9 torr. 10 to the a billion times less than the atmosphere density here. Right? And do you know who is the first international associate of LIGO? India. My friend, India is happening. Kolkata, West Bengal is not happening. Sorry to say. What are meaning behind those lighted dots? They couldn't find an answer, but in their desperation, what they did, they chose different parts of the sky, identified closely spaced stars, joined those stars through straight line, and created imaginary figures. In this way, the whole sky was divided into 88 regions, each region being governed by an imaginary figure, which we today call constellation of Taramandal. You will be asking me, these are all imaginary. Why should I know their names or their relative position? Right? We should better know the present hairstyle of Shah Rukh Khan. That is more important. Let me tell you, they have not lost their physical relevance today, right? Just to give you an idea, suppose a batch of you has gone for a hitchhiking trip, night has happened, moon is not there in the sky, and you have lost your way. Suppose somebody in the morning told you, if you go in the southern direction, there is a locality. But which is the southern direction? If you happen to see the Saptarshi Mandal, or the Big Dipper as it is called in the Western parlance, take the last two stars, join them in your mind, produce it in the sky, it will heat up a single star, and that star is the pole star. The moment you get to know the pole star, you know which is north, south, east, and west. And believe me, my friend, as somebody was mentioning, I mentioned 10-15 years back, they're still important. That's why every year for 6 nights, I have to teach the fresh batch of advanced commandos of the Indian Army how to read the night sky. Because if you can read the night sky properly, without a lot of sophisticated instrument, because you cannot take more instrument with you, because they are all radiate in electromagnetic radiation. When the scientists asked themselves the question, what is causing this white radiation, they were amazed with the answer. They found out from the surface of the sun, every second, on average, 1.6 million, 16 lakh tons of charged particles are coming out. These charged particles, as they move through the magnetic field of the sun, they produce this milky white radiation. The average velocity of these charged particles are 450 kilometers per second. At that speed, they have enough momentum. You know what is momentum? If they hit any atom or molecule, instantaneously they will break apart. Poof, evaporate. That means if I stop my lecture, go out and stand on the sun, the charged particle coming from the surface of the sun, the moment they hit my body, within fraction of a second, poof. The true color pictures of all the planets. Mercury, Venus. You do not get to see the surface of Venus covered by a thick layer of cloud. The cloud is made up of concentrated sulfuric acid vapor. So when it rains on Venus, it is droplets of sulfuric acid that falls from the sky. Right? Mother Earth. Let us not talk about her tonight. Or today afternoon. Red planet Mars. Why red? Rusting on the surface. Venus and ferric oxide covers the whole area. But this 2002 Hubble Space Telescope photograph, scientists have found a white sediment in the polar region. According to them, this white sediment is a mixture of water ice, dry ice, that is carbon dioxide ice, methane ice, and ammonia ice. According to them, even if a part of it is water ice, maybe liquid water is to flow on the surface of the Mars millions of years back. And on Earth, liquid water is synonymous with life. So was there life on Mars? Is there still life on Mars? Very big question. And sorry, let me finish up the list. Jupiter, 319 times heavier than Earth, takes 11.86 years to go around the sun once, but takes only 10 hours to go around itself. With a tremendous spin, it has dragged the clouds of the atmosphere and created these elastic belt-like structures. Till today, 80 moons. And the beauty, I don't know whether it's a boy or a girl, but Saturn is a beauty. Fantastic. 29.4 years it takes to go around the sun once. Also had 82, 83 moons. Uranus with a ring. Neptune, blue in color, covered by methane-bearing clouds. And our Nande Munde Pluto, with three of its major moons, Charon, Nix, and Hydra. It's Bake, not make. Indonesian god also. Thanks. Amazing. Whatever. 2006, NASA started a slogan, follow the water. A drop of liquid water means life. Outside the boundary of Earth, Mars is definite. Anywhere else? Yes. Europa, one of the moons of Jupiter, when they took a close-up photograph, scratch marks. So theoretically they said, the surface is 10 to 12 kilometer thick water ice. Inside, there is a warm reservoir of warm liquid water. And that liquid water is putting pressure outward, cracks are occurring on the surface. That this is true. 2016, when the Cassini spacecraft was flying over another moon of Saturn, Enceladus, hot water springs coming out. And do you know how much water has been calculated at inside of Enceladus? 1.2 times the water present on Earth. Do you know why we don't get to see these pictures when we look up in the sky? Not pollution, always. Human eye. Human eye has a problem. It's called perception of vision. Within 1/10 of a second, whatever amount of light enters through our pupil and falls on the retina, the optic nerve immediately takes them to the back of our head in the optical lobe to create an image. Our eyes cannot integrate light like a CCD chip in a mobile. If our eyes were like a CCD camera, looking in a particular direction for 10, 20, 30 hours, we would have seen almost every dot in the sky, there is a star. And huge gas clouds. This is the true picture of the cosmos. Fully formed solar system. Universe is throwing a challenge to young minds like you. You think you know everything, right? Try to understand. Then I'll know how good you are. If you are born, you have to die. How do the stars die? Stars die differently depending upon their initial mass. Stars whose initial mass is 1 to 8 times the mass of Sun. Take the case of Sun. This burning hydrogen to helium at the core. How much hydrogen remaining? Another 500 crore years, 5 billion years, Sun will be burning hydrogen to helium at the core. After 500 crore years, when all the hydrogen gets into helium, thermonuclear fusion stops, energy production stops, outward pressure stops, but gravity cannot be stopped. So Sun will become smaller. Smaller and smaller and smaller. When it is becoming smaller, in the outer envelope, shells, there's still a lot of hydrogen remaining. Because of the contraction, the temperature slowly rises to 1.5 crore, which was earlier at the center. At that temperature, 4 hydrogen nuclei again fuses, produces helium near the surface. Huge amount of energy produced, it will expand. Heated up gas. So after 500 crore years later, openly read, you will see Sun going smaller, smaller, smaller. Some it will stop and it will start becoming bigger. How big it will be? In a small calculation you can show. After 500 crore years later, Sun will become bigger and bigger and bigger and ultimately touch the orbit of Earth. Mercury, Venus and Mars, long before that, will all go inside the Sun. And much long before that, everything that you see now, including us, pure ash. The nutrient is so any star at its death produces the prebiotic material for life. Life is not special to Earth. It is universe. And that created another approach. Right? Whatever, death of stars, stars whose initial mass is 8 to 25 times. Since their mass is more, at the center initially hydrogen, helium to carbon, heavy, more pressure, more temperature, carbon to oxygen, silicon, neon, sulfur, one after another, and hence it iron. You have all studied iron has the highest binding energy. You cannot push or heat 2 iron nuclei to produce something else. No fusion, right? So, at the center, a big core of iron, then like a peels of an onion, peels of an onion, hydrogen, helium, oxygen, silicon, sulfur. This stage is the thermonuclear fusion stops. Gravity, all these layers with a tremendous force will go towards the iron core. Get a tremendous huge kick. The iron tries to compress, but beyond nuclear density, 10 to the 17 kg per meter cube, it cannot become small. So it gives a recoil. All these gas again start coming up and explodes. Supernova explosion. At the point of explosion, the temperature rises to few trillion degrees centigrade. And starting from iron 56 to 94 in the periodic table, all the naturally occurring elements get produced by a fraction of a second. Since they are produced in a fraction of a second, they cannot be produced in huge quantities. And on Earth they have a special name. They are Earth element. Literally was only created inside a star billions of years ago. You cannot produce higher elements in nature apart from hydrogen and helium, which was produced at the Big Bang. So, the supernova explosion has given us an amazing stuff that you, me, the cat, the monkey, the dog, the donkey, any plant, any insect, any animal, we are all star children. Our body is made up of stellar fossils.